As the Hubble Space Telescope enters the final phase of its life, the James Webb Space Telescope will be its successor with highly sensitive instruments and more powerful cameras, 7 times more powerful than the Hubble Space Telescope. Planning for the James Webb Telescope began in 1995, just 5 years after Hubble was launched. It is named after James E. Webb, who played an important role in the Apollo program and was developed by NASA with contributions from the Canadian Space Agency and the European Space Agency. It is currently scheduled to launch on March 2021 aboard the Ariane 5 rocket. The James Webb Space Telescope will be the largest space telescope by far. It's as big as a tennis court. Its 5-layer sunshield is 72 feet long, and its primary mirror is composed of 18 hexagonal 24-karat gold-plated mirror segments that combined create a 21-foot diameter mirror much larger than Hubble's 8-foot mirror. Its resolution is incredibly precise that it can see a penny 40 kilometers away and can be used to determine if an exoplanet has liquid water on its surface. It will be able to see infrared light, meaning that it can see objects that are farther, colder, and older, such as debris or the very first galaxies that formed just after the Big Bang. Because of its size, the telescope will be folded like an origami to fit in the rocket during its launch and unfold once it reaches space. The James Webb Space Telescope will be 1.5 million kilometers from Earth, about 4 times further from the Earth than the Moon. Because it emits infrared itself, it must be kept as cold as possible to keep its interference with itself. The colder something is, the less infrared it emits. The bottom of its sunshield will always face the sun and will reach temperatures of 85 degrees Celsius, and the other side, which houses the mirrors and science instruments, will operate at negative 233 degrees Celsius. Scientists will use the James Webb Space Telescope to search for light from the first stars and galaxies, study their formation and evolution, measure physical and chemical properties of exoplanets, understand the formation of planetary systems including our own solar system, and investigate the potential for life in other planetary systems. Thanks for watching, and keep looking up.